Hello, welcome back. So, two dimensions, okay? Two dimensions. Sometimes we need to measure the area of our house, right? Create a layout for the area of our house. And that floor plan will consist of an area measurement. How do you get that? You measure one dimension in one direction and another dimension in another direction perpendicular to your original, right? Multiply those together if it's a square rectangular room, and you'll get that square footage, right? You'll get the square footage is what we typically say, but it's actually finding the area of it, okay? People don't generally say that. What's the area of that? What they usually say, what's the square footage of it, okay? They're actually saying, what is the area that your house has? And you say it's whatever square foot. That's measuring two dimensions in two different dimensions in X or Y, however you want to label it, but two dimensions perpendicular to one another, okay? Two dimensions perpendicular to one another. And here we'll learn a little bit about that. So what we can do when we measure two dimensions, we can stay within our unit of measure. So if you're measuring in terms of feet, you have feet in one direction and feet in another. And I should label this to say feet perhaps in the X and the Y here. Feet in the X and feet in the Y. And you'll have a combined foot squared, square footage. You can do the same thing with meters, right? X, Y. Two different dimensions perpendicular to one another. Could be the area of the wall. Find out how much paint you need to buy. What you cannot do is combine two different units of measure. Say, well, I measured this one in feet. I'm just going to measure the other one in meters. Well, you can't do that. Can't combine them. Can't even combine feet and inches. You have to convert it. Okay? You won't get an accurate number. I don't even think it's really a value, combining feet and inches. But what you can do is just stay within the unit of measure that you originally measured in. Again, still you cannot combine centimeters and meters, inches and centimeters, or any other two. Okay. So what I have here below the Cartesian plane here are some units of measure for area. For typical shapes, two-dimensional shapes. Square, we can see base times height. That's really easy to see. A base times a height, okay? Triangle, 1/2, base and a height. Those are two dimensions, two different dimensions, a base and the height. Height being the Y, base being the X, okay? What's not as intuitive is when we get into circular objects, okay, like a circle. We just say, well, the area of a circle, pi r squared, right? Pi r squared. Well, what we're not actually seeing, what we're not actually saying is that those r's, because they're the same all the way around, r is the same all the way around in the x as it is the y, we can just say it's squared. But it's easier to see in terms of an oval, okay? Because an oval has two different radiuses. It has a minor axis and has a major axis, okay? Major axis on this particular oval, so it can be oriented differently, but on this particular oval, the major axis is the x-axis, okay? It just means it's the larger axis, or it just means it's the larger portion of the oval. And the y one is the minor, whatever. As you can see here, the circle is pi r squared, which is technically pi rx times ry, but for the same, we just say it's r squared, okay? But for an oval, again, you have to define r sub x and r sub y. R in the x direction, radius in the x direction, and radius in the y direction, okay? And that is two dimensions, the same as base and height for a square, base and height for a triangle, only for these circular objects, we circumscribe their edges with pi, okay, 3.1416. Thank you very much, and off to the next video.